We're going to start integration by parts by recalling the product rule. The product rule says if you want to take the derivative of the product of two distinct functions, you do it by taking the derivative of the first function, then multiplying that by the second function untouched, adding the first function untouched times the derivative of the second function. Now we're going to integrate through. So the integral of all the pieces will look like this. And I'm a little bit incomplete with my notation. I'm just using d for derivative. I'm not saying with respect to x or any other variable. So let's see what we have. We know that the integral of the derivative causes the resultant product uv to appear because these two operations are inverses and, so to speak, cancel each other. So going on over here, let's just do a little bit of rearrangement perhaps. Put the v in front, the du second, and just copy this one as it is. And then let's solve for this one. Let's leave it here and subtract this piece from both sides. So we're isolating this particular term, or integral, and we will have a resulting arrangement that looks like this. We say that the integral of u times the derivative of v is equal to u times v minus the integral of v times the derivative of u. So by using the product rule, integrating through, and then rearranging to solve for one of the terms, we see that we can solve an integration that has in it a function times the derivative of another. Clearly different from integration by substitution, where one would see a function and its own derivative sitting side by side. Very useful for functions that have no relationship to each other. You'll see that we'll be calling one a function and the other another function's derivative. Carefully choosing the two, but willing to make some mistakes to learn.